Hi sir, we are from Group 3. Our topic is District Time Signal and System. Our group members are Muhammad Mustaqim, Muhammad Shafiq, Muhammad Zakwan, Nur Fatin Shahira, Nur Akila, Gayatri and Yalen. A district time signal is represented by a sequence of values called samples that correspond to particular instant in time. The time instant at which the signal is defined are the signal's sample times and the associated signal values are the signal samples. A distinct time signal is considered to be undefined at points in the time between the sample times. Sample value of a typical signal or sequence denoted x of n and written as x equal to xn. Here, the n is distinct time index and represented as integer number. The value of xn is between negative infinity to positive infinity. The numeric value of n number in the sequence is equal to the value of analog signal x80 at time nt. The equation is given below. The spacing t is called the sampling interval or sampling period. You can see the diagram given when n equal to 0, the discrete time signal will be x0. When n equal to 1 and discrete time signal will be x1 and so on. For basic sequence and sequence operation, there are product operation, addition operation, multiplication operation, time shifting operation, time reversal folding operation, and branching operation. The product and sum of two sequences xn and yn defined as sample by sample product and sum. An arbitrary sequence can be represented in the time domain as a weighted sum of some basic sequence and its delay and advanced version. The figure shows the combination of basic sequence. First, discrete time signal value is 0.5 and the discrete time value is -2. So the first sequence will be 0.5 delta n minus -2 and it becomes 0.5 delta n plus 2. For the second discrete time signal value is 1.5 and the discrete time value is 1. So the sequence will be 1.5 delta n minus 1. For the third discrete time signal value is -1 and the discrete time value is 2. So the sequence will be -1 delta n minus 2 and so on. At last, we will get the sequence. They are the basic operation formula. Product operation is also known as modulation. To get output sequence yn, we need to multiply xn with wn. For addition operation, we need to add xn with wn. For multiplication operation, we need to multiply a with xn. For time shifting operation, yn equal to x, n minus n, where n is an integer. If n bigger than 0, it is a delay operation known as unit delay, while if n less than 0, it is an advance operation known as unit advance. For time reversal folding operation, yn equal to x negative n. The time reversal of a signal is folding of the signal about the time origin or t equal to 0. For branching operation, we use to provide multiple copies of sequence.
Okay, special sequence, unit sample sequence. Okay, the is important aspect of impulse sequence is that an arbitrary sequence can be presented as a sum of scale delayed impulse as shown. Okay, this is the calculation for special sequence, and in general, any sequence can be written as shown below inside the black box. Okay, this is unit step sequence in term of delay impulse can be written as UN equal to unit step sequence in term of delay impulse can be written as shown below, and it can be expressed as first backward difference. Okay, important in representing and analyzing linear time invariant system. General form x n equal to a alpha power of n, which is a and alpha are real, then the sequence is real. If 0 less than alpha is less than 1 and a is positive, the sequence value are positive and decreasing with increasing n. Okay, this is special sequence, sinusoidal sequence. Okay, general form as we show in the white box. Okay, and then complex alpha has real and imaginary parts that exponentially weight sinusoids as shown below.
Okay, notes about sequence. We need to only consider frequencies in an interval of length 2 pi because Sn equal to a e power of j omega naught plus 2 pi time m, and then a e power of j omega naught n time e j power of j 2 pi n equal to a e power of j omega naught n. Same like we need to consider 2 pi in formula. Then periodic sequence that satisfies the following equation: Sn equal to x n plus n the another n is the integer number. If condition tested for the discrete time sinusoidal, which require the integer, then similar statement from that e power of j omega naught n plus n, same like e power of j omega naught n. Okay, discrete time system that maps an input sequence with an output sequence yn equal to t time n time x time n. Categories of system: stability. A system is stable if and only if every bound input sequence produce a bound output sequence. Causality. A system is causal if the output sequence value and the index n minus n naught depends only on the input sequence value for n less than or equal n naught. For example, the forward difference system described by yn equal to x time n plus 1 minus xn is not equal causal because the current value of the output depends on future value of the input. Another example is the backward difference system. Yn equal to xn minus 1 is causal system since the output depends only on the present and past value of input.
For example, for question linear time invariant system, so the given for convolution sum yn that is it's equal to sum k equals to negative invalid xk h n minus k. So from the figure we have yn equals to 0, so n is less than 0. Next sequence internal show by next graph 0 less than n and less than n negative minus 1. So the output, the sequence yn, sum of n k equals to 0, a power of k is for example this graph. So step number 4, using geometric series expansion. So sum of n2 k equals to n, a power of k it is equals to a power of n 1 minus a n2 plus 1 divided by 1 minus a. So for step number 5, yn is equal to sum of n, k equals to 0, a power of k, and 1 is equal to 1 minus a power of n plus 1 divided by 1 minus a for 0 less than n minus 1. So consider next integral is 0 less than n minus n plus 1. So for our step number 7, output sequence yn is equal to sum n, k equals to n minus n plus 1 ak. So for n minus 1 less than n minus n plus 1, and step number 8 is yn equals to a power of n minus n plus 1 minus a power of n plus 1 divided by 1 minus a. Below that below is same, but it's multiple by 1 plus a power of n divided by 1 plus a. So and the final result is yn 0 1 minus a power of n plus 1 divided by 1 plus a, and then a power of n minus n plus 1 and 1 minus a power of n divided by 1 plus e. Properties of LTI, output sequence of convolution sum. So yn is equal to sum of infinity k equals to negative infinity xk h n minus k. So Hn is the impulse response. So for commutative Xn times yn equals to yn times xn. So distribution over addition, xn times h1 n plus h2 n equals to xn times h1 n plus xn times h2 n. Associative yn equals to xn times h1n times h2n is equals to xn times h1n times h2n. So the other side is graphical representation. So this one is for graph representation for system can be present a single system whose impulse the response is given by hn equals to h1n like this. So this one is for system connect in parallel.
Okay, for next subtopic is the stability and causality in terms of Hn, which stated earlier Hn is the impulse response. So if there is impulse response is absolute summable, the LTI is stable. The LTI casual if Hn is equal to 0 for n is less than 0. Causality means that the difference equations describing the system can be solved recursively. Okay, so for the necessary and sufficient condition for a causal linear time invariant that we call as LTI, the discrete time system to be both stable is given by the equation of summation of infinity, and the limit is n is equal to 0, Hn is less than infinity. Therefore, if the impulse response of an LTI discrete time system is absolutely summable, then the system is both stable. Also, for the system to be causal, the impulse response of the system must be equal to 0 for n is less than 0. Okay, next. Okay, next is the finite impulse response system, or we call in short form FIR. So FIR filter is a type of a signal processing filter whose impulse response is of finite duration because it settles to 0 in finite time. So the FIR is divided into three types of formula. For the first one is ideal delay, forward difference, and also backward difference. Okay, what is ideal delay? Okay, an ideal delay is a delay system that doesn't affect the signal characteristics at all and that delays the signal for an exact amount of time. Some delays, like processing delays or transmission delays, are unintentional. Other delays, however, such as synchronization delays, are an integral part of a system. Okay, given the formula is x, in bracket n is equal to nd, given the limit from negative infinity to infinity for value of n. Okay, so the nd must be in positive integer, as the diagram in form of line number, nd is at the center. And then for the forward difference, yn is equal to xn plus 1 minus xn, and then for the yn is the discrete time function, and then for hn is the impulse response equation, is equal to delta n plus 1 minus delta n. So given the line number line, 0 is at the center, meanwhile the negative 1 located before the 0. And then for the backward difference, yn is equal to xn minus 1. The impulse response formula is delta n minus delta n minus 1. So given for the line number system, 0 at the center, meanwhile for 1 is located at the right side of the number line.
Okay, this is the infinite impulse response system, or IIR. IIR is a recursive filter in that the output from the filter is computed by using the current and previous input and a previous output. IIR is also known as a employ feedback to generate an impulse response which lasts for infinite time. On the diagram is a feedback. So xn is the output and yn is the output. Okay, for the feedback is at least must have a one delay time and send this output of this delay step back to the input and then creating our output. For the right side is the formula for continuous time. This is the difference between FIR and IIR. For FIR is a formula for transfer function. For FIR, this is the formula between FIR and IIR. Okay, for IIR is optimization based design. Arbitrary magnitude phase response can obtain linear phase, can require large M. And for IIR is transform analog filter design, frequency selective gain, non-linear phase, no control river coefficient than FIR. For the graph is for FIR and IIR graph. And this is the basic block diagram for FIR filter and IIR filter.
Okay, to determine the difference response of the linear time invariant discrete time systems, we can use this equation, which is linear constant coefficient difference equations. And this one is an nth order difference equation. Sigma k equals to 0 to capital N a k y of n minus k equals to sigma of m equals to 0 to capital M b m x of n minus m. To calculate the value of the output, we know that the xn is an input and yn is output. When we evaluate the equation, we will get the a naught y power of y of n equals to negative sigma k to 1 to capital N aky of n minus k plus sigma k equals to 0 to capital M bkx of n minus k. The a naught should be 1. If the a naught is not 1, we should do nomination, which is simply divided the a naught to the a naught to get the value 1. So from then we can calculate the equation to calculate the value of the output. Next slide, please. This one is the recursive example. To solve the following difference equation recursively, y of n equals to ay n minus 1 plus x of n. Assume that the input is xn. We know that xn is the input value of constant k of n, and y of negative 1 equals to c. For step 2, when n is larger than negative 1, we can use the recursive computation of follows. Let n equals to 0. So when we substitute the 0 value to the n, we will get the y of 0 equals to ay of negative 1 plus constant k of 0. Since y of negative 1 equals to c, then y0 equals to a c plus k. For the third one is for the n equals to 1. When we substitute, we will get the n yn equals to a power of n plus 1 c plus a power of n k. To determine the output of n less than 0, we express the different equation of the form y of n minus 1 equals to a power of negative 1 of y n minus xn. And we also y of n equals to a power of negative 1 y of y plus n1 negative x plus n1 plus 1. If we use the auxiliary condition y of negative 1 equals to c, we can compute yn for n less than negative 1, which is negative 2, negative 3, and negative 4, and so on. And y of n equals to a power of n plus 1 c for n less than or equals to negative 1. By computing the solution for n is larger than negative 1 and n less than and equals to negative 1, we got the following solution. Y of n equals to a power of n plus 1 c. For the frequency domain representative of discrete time signal of system, we know the Hn is a impulse response. Using the impulse response to calculate the value of the output, Yn equals to Hn into the Xn. So we in the term of the complex exponential, which is exponential power of j omega. So we will get the equation h of exponential j omega equals to sigma k equals to negative infinity to infinity hk exponential power of negative k omega k. Next slide, please. And this one is the formula for the short table Fourier transform to determine the difference response the linear time invariant discrete time system. Thank you.